Hi there, my name is El-Rukby. In this presentation, I'll present an example on how to use Hadoop for forecasting based on historical data and trends. First, we'll have a quick refresher on linear regression. Then we'll discuss the example details or the problem that we are trying to solve using Hadoop. Then we'll look into how to solve it using MapReduce, but before doing that, we'll just have a quick look in Excel at the numbers and the model, and also just another quick look at how to do some of that in R. So let's say that we have these 10 records of values wherein the Y values are dependent on the X values. If we plot them, they will look something like this. Now, as you can see, they represent a general trend upward. And this trend can be represented by a line like this. And this line tries to estimate the trend points, the trend of the points. Now, one nice thing about this graph and this trend line is it enables us, if we extend the trend line, to forecast what would be the Y value for a future X value that's beyond the initial data set. So here, for example, at X equals 12, the Y is projected to be at around 110. To calculate this mathematically, you would use these functions. First, you calculate the slope using this function. Then you calculate the intercept, and this is where this trend line would intercept with the y-axis. Now, in this equation for the intercept, the n is the number of records that we have in the data set so far. So it is, in this example, it is 10, as we have 10 records. Then we calculate the value of y. The x here is the interval or period which we are trying to calculate y at in the future. So, for example, we just said that x equals 12. So y would equal a plus 12b. So basically we plug in the values of x, here 12, and the values of the slope and the intercept into the equation to get the value of y. Now this is linear regression, which is one of many types of regression calculations. There are others, and you can use that. There are others you can use depending on the data you have and other factors. Now let's look at the problem statement. Here we are using an example of a worldwide competition in which there are millions of participants. And the reason we are using an example of such scale is that we are talking about a solution using Hadoop, because the combination of Hadoop and the cloud make big data calculations much more feasible for more organizations. So going back to the example, we're saying that we are running a worldwide competition, and the target of the competition, in which there are hundreds of thousands of millions of participants worldwide. And the target of the competition is that each participant should have a total score after 10 days of at least 1,500 points. Now the table here shows the score for one of the participants at day 5. So based on the data we have so far for the first 5 days, we want to know, first, what will be the user score for day 10? So, as you see here, for day 1, there is a score of 90. For day 2, there is a score of 110. And for day 3, there is a score of 100. We want to know, well, what will be the score on day 10? We want to project that. And again, this is just for illustration, relating to regression, linear regression. And the second thing we want to know is what will be the user's total cumulative score at day 10, meaning the total points which the users scored will be scoring after 10 days from the beginning of the competition. So the idea is that would be the sum of all the y values from day 1 through day 10. The idea here is that if we forecast that the user is not tracking to meet the target number of 1500 points by the end of day 10, we would like to notify the user now so he or she can increase their rate. Now, just a quick final note on this is that this is a problem that is similar to financial applications in relating to investment or savings or 401k plans, just that there is no interest rate. So in that aspect, it is simpler. So let's have a quick look at it in Excel. So here we are in Excel, and just again, to repeat one note is that the subject of this presentation involves at least two aspects. One is a statistical model, and the other one is how to implement something like that in MapReduce. The main focus of this presentation is on the MapReduce aspect. So here we are having a quick look into the statistical model, and we'll do the same by looking at R. What you see here is data which we have collected for one user over 5 days. The X values are the days and the Y values are the scores for that user for each one of the days. So these are the X values and these are the Y values. We have those points plotted and using Excel's capabilities, and we can add a trend line. The trend line attempts to fit the points. How good is the fit is represented by the value of R squared. Now what you see here are these are options in Excel that when you create a trend line or add a trend line, you can have it generate the value, the Y value as an option, the Y equation, and display the R squared value on the chart. Now we were talking about how good of a fit. Then see here you have the R square is 0.85, which is generally it's a good fit. But it's possible, and this is using linear regression. It's possible to use different type of regression, like such as polynomial. And if we change that, if you notice that the R squared value moved up to 0.9, and if you increase the order, then it improves and it gets even to 1, where you have the trend line going through all the points. But that's kind of expensive, so you need to balance based on your scenario and your needs. So assuming linear regression, these are the equations involved in the calculation. And based on that, we expect that the value for day 10 to be 239. This is we put here that we are looking for day 10. Now, how we achieved that, and you notice that the slope and the intercept are similar to what you have here. 17 is the slope and 69 is the intercept. So we arrived at the 239 by basically plugging the slope and the intercept and the value of x of 10, so we get 239. Now, as far as what is so that is the value that we expect, that on day 10 the user, based on this trend, that they will get a score of 239 on day 10. Now, if you want to get the cumulative score for the user, one way of doing it is to generate the values for each one of the remaining days using this regression equation. So for day 6, we expect that they will, based on the trend, that their score will be 171. For day 7, it's 188, and again here we go, like day 10 is 239. The total for the first 5 days is 600. So this column adds the cumulative score from the Y values. And the total for the last 5 days is 1025. If we add the 600 to the 1025, we arrive at the number of 1625. So we expect that the user at the end of day 10, they would have a total score of 1625, which is more than the 1500 which we talked about. So they should be fine. Now Excel can arrive at the same conclusion you know, if we just apply this here, just extend it, and as you see here, it arrived at, you know, that day 10 is 239 and the total is 1625. Now, if the interest, if you have a constant rate of increase, wherein each day is 10, let's say for example, each day is 10% more than the day before, then this equation is a good equation to use. So for example, if we have here, if we change this and we say that on the second day they scored 10% more than the first day. So if we do this, say we add the 10%, and then if we extend this all the way to the 10th day, so we expect that on day 10 their score will be 212 and their cumulative score is 1434. And if you see here, this equation arrived at the same conclusion, that is 1434. And these are, by the way, the definitions for the different variables in the equation. And if you notice that the other method, if you have here the r squared is 0.99, almost, so in this situation it was very, very close, 1435. So this is just a quick introduction into how to look into applying the regression analysis into such a problem using Excel. Thank you. Okay, so now let's do the same in R. So the first thing we need to do is I need to load the document, the values. So I'm going to copy them and put them into new file. I'm going to give them the columns headers. So the first column is day, the next column is score, save, file, save. I'm going to call it, just want to give it a put it into my documents and then just save. Okay, so now we have the documents and the column values, and then we load R. I need to load the data into R. So the first thing I'm going to do is do this, read it to a table. Now header is true because as I said, you know, I have the headers for it. And so basically here we are, and as you see, you know, we have headers, day and score, open. The next thing is we'll attach to score, so R knows that all the operations will happen on it. Now if you want to plot, it's easy. Plot, and then say day and score. So this is the data. And if we want to see some of the values that we saw in Excel, such as the slope and the intercept and the r square value, we can do that easily here. So the first thing is we create the linear model. So there is this thing about the dependent and independent variables, the score and the day, and then we get the summary of the data, the analysis on the data, so do that. So what you see here is the 69 and the 17. And that's, if you look at Excel, that's what we had calculated in Excel, that the slope is 17 and the intercept is 69. And then as far as, so that's the, here 69 and 17, and then here in Excel is 69 and 17. And the same thing for R square, it's 0.85, which is the same as what we have here. R square is 0.85. Now if you want to plot the trend line, that's also easy. So we do line, and here we are. So this is how the trend line here looks like in Excel and in R. So that was a quick introduction into how to use R in a similar way we used Excel before. Okay, so let's look into MapReduce. I will go first over how MapReduce will work in this example, then I will go over the actual code implementation before running the code to process the data. So this is the input data going into Hadoop. What we see here is data for 3 participants over 5 days. So this is the day 1, day 2, day 3, day 4, and day 5, and then you have the participants 1, 2, and 3, and then they are repeated, and for each one of the participants you have the score for that specific day. In the real life scenario, we'll have data for hundreds of thousands of participants or millions of participants. So the first step is the mapper. The mapper will perform a sort and shuffle on the data to produce the data where it gets to be sorted by user. So as you can see here, we have user 1, and this is the data for user 1 over the 5 days. And the reason for that is that the output that we are seeking out of the MapReduce job is we want the information per user. Then the reducer takes that information and applies, we can apply to it whatever function we'd like to do. In this case, we'd like to apply the regression functions to it. So it will produce for us, for each reducer, for each participant, it will produce for us their cumulative score after 10 days. So let's have a look at it in Java. Okay, so let's see how we can do this in MapReduce. So we are in Eclipse now, and this is actually this file, the score, and it has the same data that we looked at in PowerPoint, where it has the days, and then for each day it has for each user per day it has their scores, and then user 1 is actually the same user that we looked at in Excel. So here, this is user 1 here, and this is user 1 here. This is the same data that we saw for user 1 in Excel. And so again, as a job, as a MapReduce job, the first thing is the driver class, which is called projection. It takes in the input is the input directory and the output directory. So the input directory is where we have the data, the input data. Then we define we tell it which one is the projection, which is one is the driver class, which is projection, and the name of the job, and then we define the types. Now the data gets passed into the mapper, Now, again, as we said, the mapper would read the files from each for each line. Will read each line and then process it. So what we have here is where I'm taking the user ID and making it the key, and then concatenating the day and the score to make that the value. Now in the concatenation there is a delimiter of the dash. Of course here you should be adding code to handle situations where there are issues with the data. But again, since this is just for demo, I'm not doing so here. And then if you go into the reducer class, what you see here is basically the reducer code. It's very simple. It's just in the reducer, I've just abstracted the calculation aspects of it into its own class called participant. But what you see here is this is the target period. It's hard-coded. Again, it's not the best practice, just for demo purposes. So, and then we are instantiating the participant class, and then calling on these methods, two methods, to get the values that we want. The projected score at target period and the projected cumulative score at target period. Printing those out so we see them, and then writing them out to the file that will go into the output directory or folder in the system in HDFS. So basically that's it. I mean, if we look then at the participant class that has the same methods that we saw, or same equations that we saw in Excel, and we are just calling them to generate the values, and then these are the public methods that we were calling from the reducer to get us the values that we wanted. Now if we run the job, and as you see here, we're passing the input and output folders as parameters. Now I had it where it will write out the results so we can compare. And what you see here is that for user 1, again similar to what we saw in Excel, on day 10 the projected score for that user is 239. And then for user 1 also on day 10 the projected cumulative score is 1625, which is the same as what we had in Excel. And then if you notice here, we have this output folder is being generated, and the results for the 3 users, which is the cumulative score for each one of them at the end of day 10, has been written out. So basically that's it. This is how to implement it in MapReduce. I'll make the code and some of the files available for you in case you need them. Thank you.